This video, I will go over arrays and answer what are arrays, when do we use them, as well as how do we use them, and finally some practice using array operations. So arrays are data structures, and they are used to basically store elements. Store elements of the same type. So for example, if we have a collection of integers and let's call them 1, 2, and 3, we can use an integer array to store these elements together, 1, 2, and 3, in an array of type integer. If we had like a collection of strings, then we can use a string array instead to store these elements together. And the way that they are stored is that they have adjacent memory location. What this means is that the elements are stored one after the other in memory, and this is helpful for traversing through them, as well as indexing and getting an element at a certain index. Another important thing to know is that we have two types of arrays. We have static and dynamic. Static arrays are what we refer to as the normal arrays. They come in a static size, meaning that once you declare an array of a certain size, you cannot change it. It cannot be expanded. Let's say we have 5 elements that we want to store in an array. We declare an array of size 5, and then that is static, so size is fixed. As for dynamic arrays, they are abstract data types, so they are implemented using arrays, which are static, but we have a set of operations. Those are abstract operations that are implemented to allow for a flexible size capacity. Dynamic arrays have consistent behavior, meaning that the operations they have follow a certain pattern. Once we reach the end of an array and reach the capacity, if we add another element to it, then it doubles in size. And this is just one of the features of dynamic arrays. We'll go over more at the end of this video. So to answer when do we use arrays, we'll go over complexity analysis of arrays and a few operations. So in arrays, we're able to access elements, search for elements, insert, append, and delete. Now, for static arrays, it takes us big O of 1 to access an element at a certain index, which is the fastest possible big O, since it's very easy to access an element if we know the index of it due to the adjacent memory feature. Searching for an element, however, takes O of n, since if you don't know where the element lies within this array, then we, at the worst case, we'd have to go through the whole array, which has size n, to get to that element, which could be at the end of the list. Now for insertion, this is not possible since arrays are fixed in size, so we're not able to insert any new elements, as well as append or delete. We could change values for existing elements in the array, but we're not able to add new ones to the existing ones. For dynamic arrays, they have the same access and search big O, time complexity. For insertion, we insert a big O of n. We append at big O of 1, since appending at the end does not involve going through the elements, or it does not increase as the input size increases, and deleting also. Deleting is like insertion, it takes big O of n, since if we're deleting an element like from the middle of the list, might have to move everything, shift everything backwards, and depending on the size of the list, this could be very large, so it's big O of n. Next, we're going to go over some operations that are useful to know when working with arrays, as well as how to declare and initialize an array. I have this code snippet. I will include the link to the whole file in the comments. You can also practice running this just to see how it works. So over here, this code is in C++. I'm doing two things here. Declaring an array and initializing an array. Declaring an array is in the following order. So first you start with a type, then you have the name, and inside the square brackets you have the size. The type could be an integer, like in this case, or a string or something else, and then the name is nums in this case. It could be anything, and in between those square brackets you have the size, which is 5, and again in a normal array, in a static array, this would be fixed and you cannot change this later on. Initializing an array has different ways to do it. This is like the most basic way, or just one of the ways to do it. You start with declaring. Here we're declaring a new array. This one is called data and has size 4. It still has the int type, and in curly brackets we're storing 4 elements. We have 6, 1, 9, 0. Those elements are all integers, so they all have the same type, and we could change the value of those elements using an operation, which I'll go over in a second, but we cannot add or remove anything from it. So over here I've included this snippet from before, since we're going to use some of these arrays to perform operations. But let's go down here. The first operation we have is getting an element. So in index 1, we're storing the value of the element at index 0. It might be confusing here. Let's just call this index 0 instead. So index 0 has the element in data which lies at the first one here, 0. Because the way arrays work is that the elements start from 0 and so on, up until n, which is the size of the... So if we had 6109, the index of this would be 0, 1, 2, and 3, and the size is 4. So in index 0, we're storing the value at 0, which is 6. So this should have the value 6. Index 0 has the value of 6. Next, we could reassign a value in the data array. So data 1s means that it's the element at the index 1, which is 1 in this case. And then we're assigning this to 0. So the array is going to be, the new array, which it's going to look like, is 6, which does not change. And then instead of 1, now we have a 0 since we changed it. And then we have 9 and 0. Then we can get the size of an array using this operation in C++. So we're storing the size in length here. And the way we do it is we use the size of keyword, and then we pass in the array name. We pass in the array name without any specific index. And in C++, array names are basically the memory location of the array. So we divide that by we dereference the array and divide by the size of that to get the size of the array. In other languages, it might be simpler, just like the dot length operation, but this is how you do it in C++, and this should give you the value for here. Another important operation to know is traversing an array, which is just going through like each element one by one. So traversing is just like using a for loop. We start from the index 0, which is the first index, up to, but not equal to the length. That is because length has size 4, but we only have 3 indexes, since we start from 0. So if we put an equal here, then that would go out of bounds, since we do not have an index at 4 here. This does not exist. So this is just important to keep in mind. And what we're doing here is just printing every element at each iteration. And if you run this would give you 6, and then at a new line we have 0, 9, 0. And this line is just printing out each element and then adding a new line. Another operation is reversing an array. So the way we do reversing is, in this case, I'm using a while loop. I'm starting from 0 and ending at length minus 1. Length minus 1 is the last index again. In this case, is 3, since the length is 4, but we do minus 1 so that it doesn't go out of bounds. So while in the first iteration here, while start is less than end, so while 0 is less than 3, we store the element at start here, which is at the first index, in temp. So after running this line, we would have 6, since start is equal to 0, and we're storing that in temp, and this is 6 here. Next, we changed or reassign the value at the first index to be the last one. So what this would look like is, we know that the last one is 0, so the new array would look like this: 0, 0, 9, and 0. So we have reassigned 6 to be 0 here. And in the following line, what we do is we reassign the value of the last element to be equal to temp. Temp is the first index before we had changed it. So we still have access to that. That's why we store it in temp. So what this would look like is 0, 0, 9, 6. As you can see, we have, going from this, we have swapped the first and the last element here. And in the next two operations, we increment the start and then we decrement the end, such that we move to the next element and the one corresponding to it, and we swap those as well, resulting in 0, 9, 0, 6 as our reversed array. The next operation is sorting. In C++, there is a built-in function called sort, which you pass in the name of the array. Again, that is the memory address of the array, which is the starting element that we want to sort through, and or the starting address that we want to sort through, and then the data plus length, which is the memory address plus however many elements we have. And this should give us the array sorted in ascending order. For example, if we sort the same array now after we had changed everything, what it would look like is 0, 0, 6, and 9. You can add another parameter to this. if you want to sort it in descending order. And yeah, in other languages there are different keywords, but it's important to know. Now this is abstract function operation, so we don't know the time complexity or what sorting algorithm it uses. So there are different ways to sort arrays. You can implement your own algorithm so that you know, or just understand how it works, just to keep in mind what the time complexity for this operation is. The next thing we have here is nested arrays, which are arrays that come in this form. So we still include the type of the array, the name, but instead of having one bracket, we have two brackets. What this means is that the array looks like this. We have a big array, which is this one, and it has the size of 2. What this means is that inside this array we have two arrays that are separated. And then the 3 represents how many elements we have in each array. So 5, 6, and 7. This nested array is usually used to represent matrices. As you can see here, this is how you declare and initialize a nested array. 2 represents how many rows we have, and 3 represents the number of columns. And the way you traverse through it is using a nested for loop. The first for loop, it traverses through the rows, and the nested ones, and the other for loop goes through the columns. The way you get the rows and columns is through these operations here. They're similar to getting the size of an array, but for getting the columns you would need to dereference the name of the array here, or the nested array, and then you reference it twice here when you divide by it. Again, in other languages this probably different, but in C++ this is how you get the size of the nested array in terms of rows and columns, and you use this in the nested for loops so that you can iterate up to rows and columns and then print out every element in this nested array. And this is how you traverse through it. Okay, so now back to dynamic arrays. So dynamic arrays, again, they're abstract data types. They are implemented usually using arrays, but they have abstract operations that are used to get a flexible size. And the way a dynamic array works is that, for example here, first we create a static array, for example nums, with a certain capacity, for example here 5. And then let's say this has like elements, like we populate this with 5 elements here. And then if we say nums dot add, which is we want to add like the number 3 to it, and if this is populated, and we're trying to add to this, then the way it works is by okay, so we have 5 elements and we're trying to add to this last here index. So the way it works is that it doubles in size. So we have a new array with the same elements in the beginning plus double this. So we have now a capacity of 10 and size 6. And there are other operations for dynamic arrays that you can use to delete, append, and insert into a dynamic array. I will also include implementing a dynamic array in the same file that I will include in the comments. So